Section 7.2, Similar Figures. Similar figures have the same shape but are not necessarily the same size. To indicate similar, we use this symbol in between the two statements. So in the diagram here they tell you that quadrilateral ABCD is similar to quadrilateral GHIJ, meaning that they have the same shape but they are not necessarily the same size. Similar figures have congruent angle measures, but they do not have congruent sides. Instead, their sides are said to be proportional. The scale factor is the ratio of the corresponding linear measurements, in this case sides, of the two similar figures. So remember, similar figures have congruent angle measures, but their side lengths are proportional. And so if we're talking about a scale factor, it's what you would essentially multiply one triangle by to make the other, or one shape to make the other. So let's say this triangle has shapes or sizes of 3, 3, and 6. And we say that it's similar to the other triangle by a scale factor of 2. Well, that, or 2 over 1, means that you would multiply all of the side lengths of the first triangle by 2 to get the corresponding side lengths of the other. So 6, 6, and 12. This can also work in reverse. You could have said that the scale factor going from this triangle back to the other one was 1/2, or 1/2. Here they ask, are the two polygons similar? If they are, write a similarity statement and give the scale factor. Well, to determine if they are similar, the first thing we do is look, do they have matching angles? The angles match up, so we're good. Then we start comparing the sides. So JM is going to correspond to TW, so that's, let's say we write a ratio of 6/6. Then we go to JK and TU, so that'd be 12/6. Then we go to KL, which is 24, over UV, which is 16. And then we've got LM, which is 24, and WV, which is 14. And so, as we can see, if we wanted to compare to see if these are all proportional, we're just going to look at what these actually equal out to be. 6 divided by 6 is 1, 12/6 is 2, 24/16 it gives us 1.5, and 24/14 is 1.7. So none of these are actually equal to one another. So none of the sides are actually, all of the sides aren't proportional. They do not have the same scale factor. So these are not similar. To be similar, these would have all needed to be the exact same ratio. So they would have needed to come out with the same values. Here they're telling us the two shapes are similar and they want us to find the values of x and y. So if we look here, x is side FG, and because they're similar, we should know that FG over its corresponding side in the other shape BC should equal the ratio of any of the other corresponding sides. So let's say we use as a blueprint DE over DA. So what we're looking here is we're going to plug in the values we know for each. So FG is x, BC is 7.5, and that should equal DE, which is 6, over DA, which is 9. And so now to solve this, we'll just cross multiply and divide, and we should get x to equal 5. We can do the same setup to find y, because for y we should know that EF over AB, that proportion, should be equal to the rest of the other proportion, in this case DE over DA. So with that, we end up with y over 5 equals 6/9. We'll cross multiply, and we should get y to equal 3 1/3, or 3.33. A scale drawing of a building was made using the scale, 15 centimeters equals 120 feet. If the scale drawing is 45 centimeters tall, how tall is the actual building? So we know this is the ratio for the scale model, so 15 over 120. And then they tell us that the scale drawing is 45 centimeters tall, and they want to know the actual building in feet. So that's what we're looking for down here. So to solve this, we're just going to cross multiply. We're solving a proportion. When we cross multiply this, we should get 360 feet. So now we're entering 7.3, where it talks about proving triangles similar. Proving triangles similar, the first way we can do this is using what they call angle-angle similarity, where if two angles of one triangle are congruent to two angles of another, then we can state that the triangles are similar. All right, and remember, similar means the same shape with the same angle measures, but the sides are just proportional. So this is angle-angle similarity. Here it's asking, are the two triangles similar, and how do you know? So in the first example, we've got congruent angle measures here and here, but we also know that we have vertical angles here, just by the design of the two triangles. Because of the two sets of angle measures, we know that yes, they're congruent, and so we can say that in this case, triangle RSW, or sorry, not congruent, they're similar, sorry, is similar to triangle VSB by angle-angle similarity. In the second one, they tell us that this angle is 30, this angle is 70. Well, right now we have congruent angles in the 70, but we don't know what the top angle is in the triangle, and we don't know what this angle is in this triangle. So if we do the math and take 30 and 70 away from 180, we find out that this top angle is 80 degrees. Well, that doesn't match this one, and chances are if we add these two up and take away from 180, we're going to get that this bottom angle in this triangle is 25 degrees. So these are not similar. Two more ways to prove triangle similarity is by looking for the side angle side similarity. So if one angle of a triangle is congruent to an angle of a second triangle, and the sides that include those two angles are proportional, then the triangles are similar. So it's kind of like side angle side congruence, except your sides don't have to be congruent, they just have to be proportional. And you're talking about having congruent included angles. So as long as the sides that include that angle are proportional and the angles themselves are congruent, you can use side angle side similarity. The last step, or the last option, is side-side-side similarity, where you have all three corresponding sides are proportional, then you know you're dealing with a similar set of triangles. So if all three sides are proportional, and they all have the same scale factor, then you can say that the triangles are similar by side-side-side similarity. Are the triangles similar? If so, write a similarity statement. So as we look here, I don't have any angles, so I'm probably going to test and see if all of my sides are proportional. So I'll take ST over VX and see if that's equal to, in this case, UT over VW, and then seeing if that's equal to US over XW. An easy way to test this is just see what decimals you get for these. So this would be 0.66 that repeats. This is 0.66 that repeats. And this is also 0.66 that repeats. So these have the exact same scale factor, which in this case would be 2/3. So yes, these are similar. And we can say triangle STU is similar to triangle XVW by side, side, side similarity. Question B will do the same thing, but we should know that from previous chapters we have overlapping angles here. So they share angle K, so we have an angle. So now let's see if the sides are proportional. So in this case we'll take KL, which is 8, over the entire length of KM, which would be 8 plus 2, which is 10. And then KP, which is 12, over the entire length of KN, which in this case is going to be 15. So 8 over 10, that's 0.8. And then 12 over 15 is also 0.8. So they are proportional. Your scale factor is 0.8, or in this case, 4/5. So we can say the triangle, let's say KLP, is similar to triangle KMN by side angle side similarity. Are the triangles similar? If so, write a similarity statement and explain how you know they are similar. So same idea here. So now we're looking at the sides here to see if they are proportional because we don't have any angles. So we'll take AC, match it up with GE. We have CB, match it up with GF, and then AB matching up with EF. So like I said before, we can find the decimal versions of the ratios, or you can reduce the fractions if it helps. So in this case, 3 over 8 is 6 over 8 is 3/4, 6 over 8, 3/4, and 9 over 12, 3/4. So these sides are all proportional. So in this case, we know that triangle ABC is similar to triangle EFG by side, side, side similarity. We'll do the same thing in B. We have a congruent angle here at A, so we need to match up the sides. So let's take AW, which is 6, over AE, which would be 12, because you add them together. See if that's equal to AL over AC, which would be 14. So if we just went ahead and reduced our fractions, we've got 1/2, and then 8 over 14 would give us 4/7. They are not the same, so these are not similar. Explain why the two triangles are similar, and then find the distance represented by x. So in this case, as we look at this, we've got angles here. We've got a right angle in the corner because hopefully they built the light tower perpendicular, otherwise it's going to be slanted. We have congruent angles here by the marking of the arcs, and angles here. So this is congruent by angle similarity. And then to find the missing measurement for x, we'll just kind of set up our proportion. We're going to have 4 feet over 10 feet equals, in this case, 5 feet 6 inches is 5.5 feet, because 6 inches is half a foot, over x. And we're just going to cross multiply to solve this proportion. And when we do this, we get that x is 13.75 feet, or in this case, 13 feet, 9 inches. Here it says for the pair of similar triangles, find the value of x. So they tell us they're similar, so we're going to have to set up a statement and solve. So in this case, if we think about similar, we know that the hypotenuses should be proportional. So let's take 39 over x plus 6 equals the legs, which in this case would be 2x minus 4 over 24. So here we're going to want to cross multiply, and when we do that, we're going to cross multiply here, which is going to end up giving us a polynomial, because you're going to take x plus 6 times 2x minus 4 equals 39 times 24, which would be 936. So at this point, we're going to go ahead and FOIL the two binomials we've created here. So remember, FOIL's first, inside, outside, last. So when we FOIL this, we get 2x squared plus 8x minus 24 equals 936. So we're essentially going to have to solve this quadratic, which can be done by factoring or graphing or the quadratic formula. I'm going to do factoring, but to do that, I'm going to have to move the 936 to the other side. So I'm going to subtract it to the other side. That gives me 2x squared plus 8x minus 960 equals 0. To make this easier to factor, I'm going to divide everything by 2 since these are all even numbers. At which point I have x squared plus 4x minus 480 equals 0. So now if I factor this into two binomials, my factored form becomes x plus 24 times x minus 20. And so now I can set each of these equal to 0 to solve for the value of x separately. So equals 0. And so when I solve the first one, I get that x equals a negative 24. Well, if x is a negative number, that means that these lengths of the sides are negative values, which is not possible. So this is not a value I want. Then when I solve the other one, I add 20 and I get x equals 20. A positive 20 works for the length of these particular sides of the triangle, and it keeps our proportionality. So the answer to this problem is x equals 20.